So yes, you can see Unacademy produced 7 trackers in top 20, 15 trackers in top 50, and 170 plus Unacademy also cracked it. We can go through the slide. And there is 35% offer going on, 20% is optional, plus 10% if you use my code Prasanna10. And there is also 9 months combo to crack UPSC Prelims 2022, 28% off with optional, plus 10% if you use my code Prasanna10. And you're going to get a series for free if you purchase 1 year subscription. And there's also 3 month festive combo, 10% with optional, plus 10% if you use my code Prasanna10. So this is a new batch starting on 3rd November. And this is scheduled for 1 year batch. And these are the educators. And this is scheduled for 2 year batch. And these are the educators. So there's also a free test series for UPSC CSE. And this is a client mentorship program. And you can also avail loan if you want, right? Yes, we'll get into the problem now. So solution, solve 1 minus x square into 1 minus y dx is equal to xy into 1 plus y dy, right? Yes. So what we will do is we will separate x and dx to one side, y and dy to other side. So let us keep this 1 minus x square dx as it is. Now we bring all the x term this side. So we will have here there is 1x. This will be equal to, let us keep this term as it is. That is, let us keep this y into 1 plus y dy as it is. Now you bring all the y term this side. So here this will be 1 minus y. So what we have did is we have separated x and dx to one side, y and dy to other side, right? Yes. Now what we need to do? We just have to integrate on both sides and we need to find the solution, right? So this is same as, I can write this as integral, I can write this as, I simplify this, after that I will integrate. This will be equal to 1 by x minus x square divided by x dx is equal to, let us keep this as it is, right? Y into 1 plus I divided by 1 minus y dy, right? Yes. Now what I'm going to do is I'm going to make some adjustment to this term so that we can easily integrate, right? So what we have here is y into 1 plus y divided by 1 minus y. So what I'm going to do is I'm going to make a slight adjustment to this term, right? Listen to this term. So what I'm going to do is I'm going to write this as minus y minus 2 minus 2 divided by 1 minus y, right? 2 divided by 1 minus y. 2 divided by 1 minus y. So 2 divided by 1 minus y dy. Actually these both the terms are same, right? I'm just making an adjustment that I'm writing y into 1 plus y divided by 1 minus y as y minus 2 minus 2 divided by 1 minus y. For example, if you just simplify this term, you will get this term, right? You just simplify this. So if you take LCM 1 minus y and just simplify this, you will have this term, right? Both the terms are same. Now integrate on both sides. So this will be integral 1 by x dx, right? Integral 1 by x dx, and this will be equal to 1x will get cancelled. So we have x dx is equal to integral minus y minus 2 divided by 1 minus y dy, right? This will be log x, and this will be x square by 2, and this will be equal to minus y square by 2 minus 2y minus, so I'll keep this 2 as constant. So integration of 1 by 1 minus y is log of 1 minus y, right? This is the required solution. So you just have to make sure that that you need to write this y times 1 plus y divided by 1 minus y as minus y minus 2 times 1 minus y, so that your integration will be very easy when compared to that, right? Yes. If you want, you can also simplify this to some more extent, right? If you want, you can also simplify this some more extent. You can take this all term this side, you can take this term this side, so no problem. So if you want, you can also simplify this to be equal to x square by 2 minus y square by 2 minus 2y is equal to log x plus 2 log 1 minus y plus c, right? So what I'm doing is I'm taking this term to this side and I'm bringing this term, that is minus 2 log y to that side, and I'm just adding the integration constant, right? Let us add the integration constant c, right? This is the required solution. is the required solution, right? Yes. So problem number 19. So solve a into x times dy plus 2y dx is equal to xy dy, right? So first we need to separate x dx and y dy to one side. So let us multiply this a inside. So we have ax dy plus a into 2y dx is equal to xy into dy. So here we have two dy terms, right? So we will group that. So ax dy minus xy dy is equal to 2ay dx, right? So if I take dy common, so here we will have ax minus xy, or I can also take x also common here, right? Okay, let me do in the second step. So 2ay dx, I can also take x common here. So x into dy is equal to a minus y 2ay and dx, right? Now you separate x dx to one side, y dy to other side. So I'll keep this a minus y dy here. Now you bring all the y term to the side, so we will have y here, right? Let us keep this 2a dx as it is. Now you bring all the x terms, which is x. Now integrate on both sides, you will have the answer, right? Now we have a minus y divided by y dy, right? We have a minus y divided by dy. Now this is same as I can write this as, so this is same as a by y minus 1 dy, right? I'm just dividing by y separately, is equal to 2a into 1 by x dx. Now integrate on both sides, it will give you the answer, right? Now integrate. So integration will be integral of a by y minus 1 dy is equal to integral 2a 1 by x dx. So this will be, so what is my required answer? So this will be equal to, so this will be log y, sorry, a log y, right? So a times log y, a is constant, integral 1 by y dy is log y, minus integral dy is y. So this will be equal to 2a is constant. So we will have 1 by x dx, right? Integral 1 by x dx is log x. So I will add some integration constant c is the required solution, right? So or you can also write this as, if you want, you can also take this to this side. So we will have, so 2ay, right? I'll just check the question once again. Yes, correct, right? If you want, you can also simplify this to some more extent, like y minus a log y minus a log y is equal to 2a log x plus c, right? This is the required solution, right? Or you can also simplify, if you want, you can also simplify that. So what we'll do is, we don't do that. Let us keep this as it is, right? So we don't need to simplify this to more extent. So it's a required solution, right? So we'll move on to problem number 20. So log of dy by dx is equal to ax plus by, right? So here there is no basis mentioned here, so you take that as e. So you just take e on, raise e on both sides. So this one, that means my dy by dx will be e power ax plus by, right? So you just have to separate dy by dx now. dy and y term to one side, dx and x terms to other side. This is same as e power ax into e power by. So this will be equal, this implies this will be equal to dy divided by e power by is equal to e power ax into dx. Now integrate on both sides. So there will be integral dy divided by, so integral dy divided by e power by is equal to integral e power ax dx. This will be integral e power minus by dy. So integral e power ax is integral e power ax by a. You will add some constant c. So this will be equal to integral e power minus by is integral by divided by minus b is equal to integral e power ax by a plus c is the required solution. Or you can also simplify this to some more extent. You can also take LCM, right? Sorry, this A. You can also take LCM. You can also simplify that, right? So if you take LCM, what you will have? So e power ax divided by a. Let us bring this term that side. So this will be plus e power minus by divided by c. So let us keep this constant as c1, right? If you take this to this side, you will have minus c. So no problem. C is some arbitrary constant. We take LCM. My LCM is AB, right? LCM is AB. So multiply this by B, multiply this by B, and multiply this by A, multiply this by A. So we will have B, solution is B into e power ax plus a into e power minus by is equal to, we will have c into ab, right? C1 into ab. Let us keep this as some constant, right? Because a and b are constant here. So therefore the solution is b into e power ax plus a into e power minus by is equal to some constant c2, right? So where c2 is equal to c1ab, no problem, right? It is just a constant. So we move on to 21. So we have y into dx plus 1 plus x square tan inverse x dy, right? So solution. So we have y into dx plus 1 plus x square tan inverse x dy is equal to 0, right? This is equal to y dx is equal to minus of 1 plus x square tan inverse x dy. So let us bring all the x term to one side, y term to other side. So we have dx divided by 1 plus x square tan inverse x is equal to, let us keep this minus dy as it is, divided by y, right? Now this I can write this as, so you just write this as, if you integrate this, integration will give you the solution. So integral dy divided by 1 plus x square tan inverse x is equal to minus of integral dy by y, right? So we know that applying the formula that integral f dash of x by f of x is equal to log of f of x, right? Basic formula. So here I'm going to write this as integral, I'm going to write this 1 plus x square as 1 by 1 plus x square divided by tan inverse of x. Both are same, right? Both are same. Actually this and this are same. So integral dx is equal to minus integral dy by y. Now I can write this as, if I take if I integrate this, this is same as log of tan inverse of x, right? You can see, so f of x is tan inverse of x, derivative of tan inverse of x is 1 by 1 plus x square, right? So it is in this form. So this is nothing but log of f of x, and this is equal to minus log y. Let us add some integration constant log c, right? So this is same as log of, so log a plus log b, so it will be log ab. So y times tan inverse x is equal to log c, or c is equal to y times tan inverse of x, right? C is equal to y times tan inverse of x is the required solution, right? So very easy problem. So you just have to make sure that you are using this formula, integral f dash of x by f of x is log of f of x, right? Yes.